Thank you, sir. So we are expected to follow this 7 step in solving analysis of variance or FS or ANOVA. So I maybe use this name interchangeably, which means if I say analysis of variance, it's the same thing as ANOVA and the same thing as what FS. So in calculating the computation of F calculated value, right? So we have we have treatment TRMS divided by RMS. So this is calculated what? Value. Calculated value. And TRMS is the same thing as treatment mean square. Treatment mean square. Let me just explain the formula, but by the time we begin to solve now, you understand more, right? So why the Rn is the same thing as residual mean square. Residual mean square. Class. So how do we get the treatment mean square? So the treatment mean square is equal to TRSS divided by K minus 1. K minus 1. So TRSS is the same thing as treatment sum of square. It is same thing as treatment sum of square. Why K minus 1 is the degree of freedom of treatment. The degree of freedom of treatment. Sorry. Why the K itself is known as what? Treatment. Is known as what? Treatment. We call it treatment because let's assume we have A, B, C like that. So each value that we have in each letter here is what we call treatment. A, for example, represents treatment on its own. B represents treatment, and C also represents another word, treatment. So we can have up to 4 or 5. Remember that we say that F test can be used to compute or test the comparison between 3 or more variables, right? 3 or more variables. Now, let's continue. Now, to get residual mean square now, RM. So RMS is RSS divided by N minus K. So the RSS is equal to residual sum of square. It's equal to residual sum of square. Why the N minus K is equal to degree of freedom. Degree of freedom of residual. Degree of freedom of residual, right? So also, remember that the K is the same thing as treatment. So this big N here, capital letter N, right, is known as the total number of observations. It's known as total number of what? Of observations. So also class, Now, also take note that TSS, TSS is equal to TRSS plus RSS. So this TSS here is known as total sum of square. TSS is known as what? Total sum of square. So I know the treatment sum of square. This is treatment sum of square. Why we call this residual sum of square or error sum of square? So the addition of these two will give you total sum of square. So which means if I have treatment sum of square and I have total sum of square, I can easily get residual sum of square. Now, class, my residual sum of square using this analysis here will be total sum of square minus treatment sum of square, right? I can write this like this, right? Because the total sum of square is equal to treatment sum of square plus residual sum of square. So let's say I have the information of treatment sum of square and I have the information of total sum of square. For me to get residual sum of square, I can make this sort of formula, right? So the residual sum of square will now be total sum of square minus treatment sum of square. Now, how to calculate all this? How can we calculate this? Now, how to calculate? How to calculate TRXS, TXS, right? And RXS, and RSS. Class, take note that to calculate TRSS, TRSS is calculated as, now, let's say we have A, B, C, like I said, right? The total of each treatment is what we consider here. The square it. For B, let's say we have B, the square this B also. Let's say we have up to C, the square this C, right? Divided by N. Class, take note of something here. Take note of something here. If the number of treatments given to you is equal, you know this N means the total number of each treatment is different from big N. Take note. The big N is the total number of observations given to us. While the small N is only the observation of each treatment alone. Of each treatment alone. But there's something that I wanted to explain here. If the number of treatments is the same, class, you can divide everything by N. If the number of treatments is the same, you can divide everything by N. But if the number of treatments is not the same, I can divide each treatment with a separate N. Now, this is what I'm saying, class. Let's say here we have 2, 3, 4. B, we have 4, 1, 5. And C, we have 6, 7, 8. Right? When you count each number, this is treatment 1, treatment 2, treatment 3. When you count each number here, you notice that we have 1, 2, 3. We have 3 here, we have 3 here, we have 3 here. You can divide all by 3. But in a situation whereby the number given to us in each treatment is not the same, let's say I have 5 here, I have this here. So I have 3 here, I have 5 here, and I have 4 here. Please, in that situation, you are expected to divide each treatment with the number of observations given to them, which means here will be divided by 3, here will be divided by 4, and here divided by 5, sorry, and here will be divided by 4, right? But in a situation whereby we have the same number all through, right? We have the same number all through 1, 2, 3 class. I can rewrite this to be divided by n, which means everything divided by 3. Please take note. Take note. Now, this minus g square over n class. The g square over n, we call it correcting factor. Correcting factor, right? And the n is the same big N that you know, which contains all the number of observations. Now, 1, 2, 3 here is the small n, but all the numbers given to us is representing what? Big N. 1, 2, 3, 4, 5, 6, 7, 8, 9 is our big N. Total number of observations of all the treatments. While the small n represents the number of observations in each treatment. Please take note of this. But the G square here, is the grand total. Okay. Ifeanyi Okoro, please go ahead.
Okay, sorry, I just want to confirm what you said recently. You said the G square over N is also known as correcting factor, or is it just the G square or G square over N that is known as a correcting factor?
G square over N, the total of this is known as correcting factor.
Okay.
So G, thank you. N alone is total number of observations, while the G is called a grand total. Grand total. G alone is grand total, N alone is total number of observations, but the G squared divided by N is called correcting factor. Correcting factor. Now, how do we get the G square? This G here is total number of this, total here, total here. So when you have the three together, you have the G square. Now, what we have here is what class? This is 9, right? What do we have 10 here? Here we have this is 15, 21, we have 31. Now, what is the total of this? Now, this will be 30, no, 40 class. 40. So the G here is representing the total of observation here, which means G what? G will be 40 raised to the power 2, and the N will now be what? 9, right? So the total number of observation is this big N, while the grand total is all the summation of the total of the each of the that we have. You can get what? Treatment sum of square. You can get treatment sum of square. Now, how do we get total sum of square? So for total sum of square class, total sum of square is summation y square minus correcting factor. Right? You can see summation y square minus correcting factor. Right? In some other textbooks, they can use any variable to indicate this y. But what does it mean? We understand the correcting factor now, right? That G is the grand total square, while the big N is total number of observations. Now, the summation S square, this means that we are expected to sum each value. Now, like when we have this A to be 3, 2, 1, we have B to be 6, 1, 3, and we have C to be 1, 2, 6, right? So for us to get this, right, that okay, thank you. So for this, we are expected to sum, you sum and square, that is 3 raised to the power t plus 2 raised to the power t plus 1 raised to the power t. Then you move to other treatment, 6 raised to the power t plus 1 raised to the power t plus 3 raised to the power t. You move to the other one, 1 raised to the power t plus 2 raised to the power t plus 6 raised to the power 2, right? This is this, right? The summation from y square, which means you sum each value, you square each value that we have on the treatment, then you add it together, right? You add it together. So that will give you this minus correcting factor, minus correcting factor. So if you have the total sum of square plus residual sum of square, we can easily get our, when you have treatment sum of square and total sum of square, we can easily get our residual sum of care class. We can easily get our residual sum of care. And this is method we are going to use today. And all this process, it is only applicable for F calculated. It is applicable for F calculated. Applicable for F calculated, then we follow the other process by checking the statistical table for, F tabulated. Class, if you are ready, I'm ready. Now, there was a particular question that was sent to our group now this evening, right? So you see this, the question is describe the term analysis of variance. Describe the term analysis of variance. And I just explained this now that the F test is the most appropriate test for three or more variables, right? For three or more variables, and the F test is simply the ratio of two variances, right? It seeks to analyze the variance among three or more populations by comparing the average variation due to treatment and residual, which is also known as error. That's number 3A, which is also known as error. But now, look at the B part. Look at the B part. Now, the table below shows the yield per acre of 5 different vegetables treated with 4 different types of fertilizer in Unilag. In Unilag, right? In Unilag agro farm. Using the log method, it's the same process here. Whether log method or not, it's the same process. And if you check your module, you also use this, method. So determine whether differences in yield per acre due to the fertilizer per acre, A due to the fertilizer and B to the crop at 5% significant level, right? So which means for us to check the table, you are expected to check at 5% level of significance. Now, class, before we begin to solve this question now, how do we check the statistical table, right? For F test. Statistical table for F test is level of significance here, right? Level of significance V1, P2, comma P2, right? So the P1 here, we can rewrite the V1 to be the degree of freedom of treatment, right? Which is minus 1, K minus 1, and the degree of freedom for residual, which is what? N minus K. N minus K. Which means for us to check this will be 0.05 under, which means how many treatment do we have? Minus 1. And the total number of observations minus the number of treatment given to us. So at the end of the day, we can have F 0.05, maybe for P1, 2, and this 12. So the analysis is there from the table. You see V1 and V2. Or some statistical table, you can see F1 and F2 class. It's the same thing. So the degree of freedom, we are checking the degree of freedom for treatment and the degree of freedom for residual under the percentage given to us, which is 5% in this scenario. So some other, exam or question you can have any other percentage apart from 5. But it is only when we are not given the percentage that we are expected to use 5% in economics. But in this scenario, we have a particular word percentage that the examiner want us to use. Now, in solving this question, class, in solving this question, right? In solving this question, we have the treatment now. If you check this question very well, class, I hope you all have access to this question, right? Oh, class, in case if this the app not give you out, please kindly click on the same link again to rejoin. Please, sorry for that. Kindly click on the same link again to rejoin the class, right? So now, fertilizer now, it is split that we have items slash crops. fertilizer A, fertilizer B, fertilizer C, and we have fertilizer D, which means, which means we have four different variables here that the examiner wants us to what? To consider. To consider, right? To consider. So we have, ugu, green, bitter leaf, scent leaf, ewedu. So we have something like that. So let's analyze this. Let's say for A, under A, you don't need to write the ewedu and the other. So under A, we have 5.5, 9.7.9, sorry, 6.1. Then we have 5.8 under A. Now, under B, fertilizer B class, we have 7.9, we have 8.8, we have 9 point, sorry. Sorry. Okay, under A we have 5.5, 6.6, 7.4, 6.9, and 7.2, right? This is what we have under A. Then under B, I hope you can see the board class. And under B, we have 7.9, we have 8.8. If you have any question, please you can put it on comment or you can raise your hand. 9.9, 8.3, and 6.3, right? So under C, we have 6.1, 7.3, 7.3, we have 8.4, we have 5.9, and we have 6. Why for D, for fertilizer D class, we have 5.8, we have 8.5, we have 6.7, we have 7.5, we have 5 point what? 5.6, 5.6, right? Right, 5.6. So like I said, that we are expected to follow the 7 step we have in testing. So the first step here, class, will be statement of hypothesis. Hypothesis. And how do we illustrate this? So your HO and H1, right? So for HO, you can say that the fertilizer A is equal to the population of fertilizer B, because we use mu, right, as population, right? So that's equal to B. The B is equal to C, and the C is equal to what? The D, right? This is how we analyze, the level of statement of hypothesis for F test. And the H1 will now be that no, that the A is not equal to B, because the intention of, the researcher is this is equal. But our own, the reason we are testing is just to confirm the claim of the researcher, whether it's right or not, right? So we say that C is not equal and is not equal to what? To D, right? This is how you are going to specify the statement of hypothesis. Sometimes if you have up to E, you continue like that. And if you don't have up to D, you stop where, you stop where you have the data on, right? So the second one, which is the level of significance, right? Level of, please follow this step, please. Level of what? Significance. Under the level of significance, here we have F to be 0.05, right? Which is 5%, 0.05. Now, we can easily get our the K minus 1 class. What's the K minus 1? How many treatment do we have? This is treatment 1, treatment 2, treatment 3, treatment 4, right? So when you say 4 minus 1, we have 3. We have 3 here. 3, comma. So this 3 representing is B1 or F1 in case you are checking statistical table, right? So, okay, Fiki, can I hear from you that say something? Can I hear from you? You don't understand or what? Hello? Okay, let's continue. So the N minus K now class. So our N, what's the total number of observations given to us? When you count this, 1, 2, 3, 4, 5, right? Thank God that it's equal. Everything is equal, which means we have 5, 10, 15, 20 class. This is 20, which means the big N here will be 20 minus the number of treatment given to us, which is 4 class. What do we have? We have 16. So the N minus K will be what? 16. So when we check the statistical table for this class, we are expected to check.
Sorry, sir. Please, can you bring the calculation up?
Okay, are we just no, I'm just trying to find degree of freedom for residual, which is N minus K, right? And our N here is total number of observation. When you count it, you have 5, 10, 15, 20. This is 20 minus treatment, which is treatment 1, treatment 2, treatment 3, treatment 4, minus 4. So this will give us 16. So at the end of the day, for us to check the F statistical table, right? So we are checking sorry class, let's continue. So we are taking F for 5%, 0.05, F1, 3, and F2, 16 at the end of the day. F2, 16, right? So the next step is computation of F calculated. Computation of F calculated, right? Computation of F calculated. But I wish to move the table up. But before that, class, before that, what's the total of this, total of this, total of this, and total of this class? Let's do this together. Let's do it together. What's the total of this? Because we need it to calculate the F calculated using those different formulas. So that I can move, once we get the total of this, then I can move the table up. I'll just clean the table, then we continue solving. Please, I'm waiting. What's the total?
A is 33.6.
God bless you.